Alright, welcome to part 3. Okay, by now we've done all of these. We're ready to start on Orthocenter. Okay. Alright, so Orthocenter is the one that's made up of altitude. You notice I'm kind of trying to do all these in the same order. And you'll see why in a minute. Okay, so altitudes are the things that make up the Orthocenter, and guess what? Yes, all three altitudes... Try to not make this look like a right triangle. It's kind of hard. All three altitudes, so like maybe that's an altitude, and that's an altitude, and this would be an altitude. Guess what? They'll intersect in the same place, and that is the orthocenter. Okay, this is not perpendicular bisectors. Yes, these are perpendicular, but they're not going through at the midpoint. These are perpendicular, and they go through a vertex. That's an altitude. The three altitudes of a triangle will intersect in the same place. Now, if those... You know what? I think I can do a more difficult one. Okay, fine. Whoa. Okay. I'm going to change this triangle just because it's going to make it more interesting. Yeah, here we go. We didn't really talk much about what happens if you have an altitude that goes outside the triangle. That is known to happen. And you know what? I think I'm going to need some more room. I'm going to put this up here a little more. Okay. On the test, of course, I'd make sure that everything's going to fit, but on this thing, it's kind of hard. Okay, so altitudes. Let's do one at a time. I think the easiest one is maybe the altitude from A over towards BC. So let's do that. Again, we're looking for trying to make the perpendicular that goes from A to line BC. I need this to cross the line twice. Is that going to cross twice? It looks like it is. Okay, so let's go ahead and draw that. Crosses the line twice. Then I need to find the perpendicular bisector of that segment I just cut off on that line. So here you go. Here's your swoop. We're making the football here. Do the same thing at both corners. Am I right on that thing? I'm pretty darn close. Okay. So here we go. I have constructed the altitude now. Whoa, that really flipped around. Constructing. I'm working on it. Oh, I missed a little bit. The altitude that goes through A and is perpendicular to, I'm a little bit off because of where I stabbed, and the line is never going to work just the way I want it. Alright, it goes right. Now I'm going to extend this because this thing, I told you I'd do this on purpose so that it would go outside the triangle. I have a hunch I'm going to have to extend this even farther. We'll see. I probably missed just a little bit there, but there you go. Your constructions look the same, so you know. You got to give me a little leeway here. Okay, that was the one from A to BC, and really the altitude is just this part in here, but the orthocenter may not actually be on that segment. Okay, constructing the altitude from B to AC is not quite as easy. B's up here. Here's the point. Here's the line, AC. The perpendicular that connects those things is going to, if you can imagine this, it's going to kind of have to be over here. Like, we're talking about the perpendicular from the point to the line. So I don't just mean side AC. Come on, get down here. I mean the actual line AC. Is that going to extend it pretty well? That's close enough. So it's legal to do this. Of course, this is a construction. You can use your straight edge. Line AC looks more like that. And yes, I can go ahead and extend that. And why does it keep doing it? Stab here. Let's make the perpendicular from that point now to this line. I make it big enough so it crosses twice. Now look at how much junk is in my way. Wow. Okay. Now I need to make the perpendicular bisector of that thing. Let's get this a little shorter here. Stab right there, make a swoop. Boy, I'm glad I changed color. Whoa, it's a big swoop. Yeah, right about there. I'm trying to stab right here on this thing. Make my fish here. Yeah, because look at all this junk that's in the way now. I have a lot of other stuff. Okay, trying to connect the dots on my fish, or my football. So that's supposed to go through B and be perpendicular to line AC. Well, if I extend it far enough, guess what? I eventually find the place where it intersects the first line. And yes, this is what I'm looking for. Look how far outside the triangle this is. This can happen with orthocenter. Orthocenter can easily be outside the triangle. It happens whenever the triangle's obtuse, just like circumcenter can be outside the triangle when the triangle's obtuse. Alright, so back to the first. I've shown you all the sort of level 1, 2, and 3 things about these constructions. Let's get rid of all the annotations here. And if you haven't noticed, angle bisector, I did this on purpose, angle bisector is the one that goes within center. Perpendicular bisector, if you construct two of those are actually three of those, they'll intersect at the circumcenter, the medians meet at the centroid, and, oh, do I have any more colors? The altitudes meet at the orthocenter, and those things kind of all go together. Back to my color system here. Angle bisector was of course the only thing involved in center and finding angle bisector. Perpendicular bisectors and finding the circumcenter, of course, perpendicular bisector is the construction you need for that. But also for medians, you also need perpendicular bisector because that's going to locate the midpoint in there to connect to the opposite side to make the median. And for perpendicular from point to a line, that's how you make an altitude. Okay, continue with this little color scheme here. The in-center has a cool property. I'll just tell you right now, it's going to have to do with that thing. The circumcenter has a cool property. It has to do with that thing. And oh my gosh, the 9-point circle is like the one ring to rule them all. It's like, you want to see all this stuff in one place, head to the 9-point circle, okay? 9-point circle is the coolest thing of all. It involves actually all this stuff. Would I ever actually ask you about the 9-point circle on the test? Probably not. Could I show you the sketchpad? Yes, and it's very cool, and then you can move things around and see how that works. In fact, speaking of sketchpad, let me show you this. I've put all these things in one document. Here's the angle bisectors in the in-center, all that stuff in one place. These are all constructed to be angle bisectors, but what's cool about sketchpad, of course, is you can move stuff around and it stays that way. You could do this yourself on sketchpad. It doesn't take that long. That's what that one looks like. Ooh, is my color scheme the same? Not quite. This is the medians and the centroid. But of course, on sketchpad, what's kind of cool is I could show both those things at the same time. You might be thinking, well, those look really close. Angle bisectors and medians seem to look really close to people a lot because they always have to go inside the triangle compared to some of this other stuff. But those two centers aren't the same. If you have an equilateral triangle, of course, everything's really friendly and angle bisectors and medians are the same thing. But in general, no, that's not true. It can be pretty wacky. You don't know that. Let's get those out of the way. Here's the perpendicular bisectors of every side and the circumcenter. And that could go outside the triangle if the triangle's obtuse. These are all perpendicular bisectors. And then we have altitudes. And these are going from the corner to the outside and perpendicular. And again, if the triangle is, whoa, that really goes out there fast, doesn't it? If the triangle is obtuse, it goes outside pretty quickly. What's kind of cool about Sketchpad is you can show all those at the same time. And you can see how things operate and how those things kind of go crazy. You kind of notice there's some cool relationships among the things. Sometimes some of these look collinear. Turns out that 3 of them are always collinear. Can you tell which 3? Oh, it's those 3, and that little relationship there is called the Euler line. Euler is one of my favorite mathematicians of all time. I don't know about you guys. The in-center is the one that doesn't behave there, but guess what? Orthocenter actually plays nicely. Orthocenter is the weird one, I think. But in-center is the one that doesn't fit this line all the time. That line can sometimes go outside. The midpoint of that line, that Euler line, is well, I'm getting ahead of myself. I should wait on that. Back to one of these centers at a time here. Because this is what I was about to show you. If you did the in-center right here, the in-center is actually a center of a circle. It's called the center for a reason. It happens to be the center of a circle that does this cool thing. You see what's going on here? That circle is the center. Sorry, that circle just happens to be tangent to all 3 sides of the triangle. Even if the tangent's wildly obtuse, the in-center will be the center of that triangle. The circumcenter, which is the perpendicular bisector one, that's the center of this circle that's going to hit all 3 corners of the triangle, no matter what. The center of that circle is the circumcenter. The other properties here are the median, which I can't really show you. The medians make the centroid. This is also sometimes called the center of gravity. If we were to make this triangle out of some uniform material like steel or cardboard or something, you could put your finger on here and it would balance, sort of like a table, on the centroid. That doesn't really show up in a geometric property. But the orthocenter, wow, that's not, what's hard about that one is, when people ask, well, what is that the center of? It's really hard to answer that. I can't even tell you what that's the center of. But it is cool that, in the ways that it behaves with these other these other centers, it's collinear with the centroid and the circumcenter. Alright, so there's one more circle to explain, and that's the 9-point circle. The 9-point circle is centered on the midpoint of that little line segment. So as I move this around, look at the black segment. I have the center of it labeled 9. The midpoint of that segment will always be the center of this thing called the 9-point circle. Now, can you keep track of all this stuff going on? That 9-point circle, see if I can make a nice example that kind of goes through lots of things. There are 9 critical points that this circle will always go through on the triangle. It goes through the midpoint of every side. It goes through the foot of every perpendicular. Do you know what I mean by that? The perpendiculars, of course, were here, the orthocenter. Orthocenter is where it is the altitudes. Notice where each altitude crosses the side perpendicular. The 9-point circle hits that. See, the 9-point circle hits this point. The 9-point circle hits this point. 9-point circle hits this point. So that's 6 of the 9 points. The other 3 points are really kind of hard to explain. They are the midpoints between. Let me see if I get this right. They are the midpoints between, I think it's the orthocenter and the vertex each time. Those midpoints, or sorry, maybe it's the incenter and the. No, it's not the incenter. It's not. Anyway, there's another 3 points. You can look it up. It's crazy, and it works no matter how you draw this triangle. I think it might be the orthocenter midpoints between the orthocenter and the vertex. That's kind of what it's looking like to me. Anyway, all 9 of those points have to be on this circle. That's a crazy property that Euler figured out many years ago. Okay, so back to where you were here. I was about to show you inscribed circle. I'm running out of time. Circumscribed circle is more fun. I'll start with that one, and then we'll do inscribed if we have time. All right, so what we're looking for here is the perfect circle that actually, wow, that's really bad. There's a perfect circle that, okay, somewhere. There's a perfect circle that's going to contain all 3 of these corners. It doesn't look anything like that. I can show you. It's going to look a lot better. Just to make myself some room here, I'm going to move that down a little bit. All right, so circumscribed circle, that's the one where I need the circumcenter, and the circumcenter is the one where I need perpendicular bisectors. So I'm going to need my tools back. You know what? We're at advanced level now. I'm going to cheat on that whole straight edge stuff. All right, so I need the, I still have this crazy color, fine. I need the football on AC. I really just need 2 of them. AC is nice and horizontal looking, so I'll do that one. And for my straight line, I'm going to cheat. I'm going to use this tool because it's a lot faster and probably more accurate. You have a straight edge, but I'm going to do that. Oh, I don't want that color, though. I should take this color. Okay. So right from there, straight, what? Try to change color. Try that button. Okay. And what? There we go. That's a little thick, but okay. It's the perpendicular. I missed, so I might as well change the thickness. Sorry you had to watch me do that 6 times, and something like that. Okay, now we'll change colors. We'll do this one red, and we'll do the perpendicular bisector of, let's say, AB. Why not? So I need to stab it at B, make it a little smaller, and let's swoop one side of the football. Swoop. I think I'm going to be off here because I'm in a bit of a hurry. Is that better? That's not bad. Swoop the other side of the football. Use my cheater tool to draw a straight line that way. Okay. And look where those intersect. Those intersect right around, oops, right around this. So it's this line and this line. So this ought to be the circumcenter right there at that point. Well, to draw the circle, all I need to do is start there and target one of these points. It looks like I could just about hit A right there. Let's get a different color, and let's go ahead and draw this. Now this circle ought to hit all 3 points. It hit A, it almost hit C, it's pretty good for me, and B, yes, not bad. So that's kind of cool. It's more accurate on Sketchpad, but it's kind of cool to do it by hand and get there. I'm not going to have time to do the other ones. I explained them while I was talking about the Sketchpad stuff. It's a little beyond test level. No way would I ask you to even talk about or let alone construct the 9-point circle, but you know, it's kind of fun. You can look it up on Wikipedia. It's great stuff. Okay, I'll see you in class. Thanks for watching.